Hello friends, hope all of you are safe in this lockdown situation. I am Dr. K. Deepan from Tamil Nadu, India. I am basically a solar and electronic hobbyist. In this video, I like to share some of my closed observations or views on a product, which is nothing but a solar product. The product is UTL Gamma Plus Solar Inverter, which is equipped with advanced RMPPT technology, using which the company is claiming that 30% more efficiency can be achieved using the inverter. I really, like the product. For the past month, I'm using it. I'm really liking the product. Hence, I just wanted to share my views on the product with you all. And primary need of this video is to demonstrate how much money we can save even with a small scale solar installation. First, in this video, I'll give a small introduction, or I can say specification of the product, and explain how easily the inverter can be configured for our needs, specifically for our needs. At last, I'll give you a idea how much this particular inverter helped me to save some of my money. Okay, and friends, in this video, I'm just sharing my own views on the product. Here, I like to say one thing. I'm not a brand ambassador for that particular product, and here I'm not here to promote the product also. Okay, maybe you can take this video as a customer review. Look and feel. On seeing the inverter, I can say that the design team of the company has spent so much of their time in a design perspective, that is attraction of the color of the inverter is very attractive one. It is coming in golden color, which is unique, that I haven't seen this color in any other inverters. And second attractive thing about this inverter is the largest LCD screen, which displays all the parameters of the inverter. It always informs the user of the inverter. The next thing is all the controls are through digital button switches. This is good that we don't need to turn back the inverter to change any of the settings. All the settings are available from the front side itself. Now, if you come to the back side of the inverter, the solar connectors are just a normal connector with the solar reverse indicator at top of the connectors. In this point, what I feel is if the connector is MC4 type, then there won't be a chance of reversing solar polarity, right? So maybe the company can think on that. Next, the power connectors are ordinary plug type connectors alone, which is a good one. And AC fuse is provided in the back side. And coming about to the fans, there are two fans are available in the inverter. One is in the side, another one is in the back side. I hope one is for the transformer, internal transformer, another one is for charge controller, I hope. Since there are two fans are available in the inverter, I feel that it may create some noise that resists us to install these inverters inside the bedroom. Why I'm saying this point means most of the houses in Tamil Nadu, they are having the plug points or arrangements for inverter in the bedroom itself. So the fans, two fans, which can make some noise, will resist the inverters to be installed inside the bedroom. Now, coming to the specification part. Here, I'm not going to explain all the specification. I'm going to explain some important specification in the user point of view or the customer point of view alone. After reading the technical documents of the inverter and also by seeing the working of the inverter personally, I prefer to call this inverter as a solar PC instead of solar inverter, though the company is also calling this particular inverter as a solar inverter, since it is an integrated system having mostly all the functions of a solar PC, like It's having a solar charger, it's having an inverter, it's having a grid charger, and it's having a source selection mechanism and some control algorithms also. And one more reason is this particular inverter, especially in my home, the daytime load is roughly morning 7 a.m. to 6 p.m. Most of my load is running through the solar itself, right? The second important specification about the system, here we don't need to bother about the solar panels volt. In most of the inverters, for example, if it is a 12 volt inverter, we must use only the 12 volt panel. But here in this UTL Gamma Plus 12 volt system, we can use 24 volt or 12 volt solar panels, which is a money saving option in solar panel buying, right? Why I'm saying this is normally a 12 volt 150 watt panel cost around 6,000 rupees in market, but we can purchase 24 volt 250 watt solar panel almost for the same cost. The third specification is about its solar panels power. Okay, since it is a 24 volt system, we can go up to 1000 watt solar panels within the current limit of the charge controller present in the inverter. Normally, if it is a 12 volt system, in any other brands, we can, for this particular 1 kilowatt inverter, we can go up to 600 watts solar panels. But here we can go up to 1000 watts of solar. Next important specification, the MPPT. Normally, the MPPT, the maximum power point tracking charging technology, is available in commercial inverters alone. But here, the MPPT is available in the domestic lower power off-grid inverter range. That is one peculiarity of this inverter. As I have mentioned earlier, the company is claiming 30% more efficiency, which is true due to the MPPT technology present in the inverter. That 30% more efficiency can be realized from this particular graph. This graph is simply a power graph of the solar panel, and here any of the PWM based inverter available in the market will omit the voltages higher than the battery voltage. Hence, the maximum power that we can produce from the power we can use from the PWM based inverter is 600 watts. But since this particular Gamma Plus is having MPPT technology, inverter is going to derive the power in its maximum power point of the panel. So we can derive 850 watt power. So if you compare the 600 watts of PWM based inverter to this particular 850 watts, the efficiency is somewhat 30% higher. I hope that's why the company is claiming 30% more efficient. The inverter is having one more specification which is worth mentioning here. That is its display, right? The display is multicolor display, means it always informs the user about the condition of the inverter, in which mode it is working, and what power it is generating from the solar, and how much power it is giving to the load, and current voltage. All those things you can get it out of the inverter in this LCD. And one more thing is, the LCD is a multicolor display, right? The color of the display is changing with respect to the operating condition of the inverter. For example, if it is in red color, it says that the inverter is working in protection mode. If it is in green color, it means the inverter is working only in solar or battery. Means mains power is not coming into the inverter. And if the color of the LCD is turns into orange, it means that the inverter is working with solar and grid power. As I have told you earlier, the UTL Gamma Plus is an advanced PCU having three working modes. They are Smart Mode, PCE mode, and Hybrid mode. The first two modes are for the urban users, and the third mode is for village users. The first Smart mode is solely for urban users who cares less about their electricity bill, and the PCU mode is for once again the urban users who really cries on their EB bills. And the third one, the hybrid mode, is for the village users who are getting the grid power for lesser time compared to the urban users. Okay, and in smart mode, the inverter gives more preference to solar than the grid power and then the battery. Here, what I have noticed in smart mode is the inverter changes over automatically to grid once either the solar current or voltage is zero in the evening time without using the battery further. In PCU mode, the inverter gives more preference to solar than battery and the grid as claimed by the company. My inference on this mode is that the inverter is still feeding the load from the battery even after the solar is absent. And once the battery charge is coming below a preset voltage of around 11.5 or 11.8, then the inverter switches over to the grid, which is the exact PC mode available in any other brands. But here we have to be aware that the battery cycle is being spent every day, which leads to the change of batteries every 3 or 4 years at the maximum. In the third mode, that is the hybrid mode, the inverter mostly prefers the grid power over the solar and battery as claimed by the company. Out of these three modes, I prefer to go with the smart mode since it uses the battery less, hence the battery life can be extended for few more years. And to set or select the modes from the controls, we have to press the boost charge enable disable, the curved back key for 15 seconds. Then the three modes will be available to change from the up and down arrow keys as we can see from the LCD screen, and then by the enter key. Okay, so we can change the modes from the up or down arrow keys and then by pressing the enter key. Now coming to the batteries and charger settings, the UTL Government Plus is having a dedicated button to select a battery type, that is either the Duplar or sealed maintenance free batteries. Here if you press thrice the button given for that settings, the battery type will be changed, and also the preset battery voltages and current are being called for the battery type selected. Here one thing to be noted is the inverter charges the batteries in three different stages as shown here to enhance the battery life. The stages are bulk mode or constant current mode, which is needed to charge the deeply discharged batteries, and the second mode and third mode are absorption and floating mode called as constant current mode. Here in the floating mode, a minimum amount of current is being given to the battery in order to enhance the battery life and also to avoid the regular refilling of the electrolyte water into the battery. So these different charging stages are advantages in this particular inverter. And here the inverter presumes the tubular battery type as the C10 battery alone. But if we have to use the C20 battery with the inverter, we have to reduce the charging current to 8 amps instead of 16 amps for C10 batteries. To do this, the Gamma Plus is having a fully configurable recipe of current and voltages suitable for the battery, which is going to be used with the inverter. To customize these settings, the up arrow and the curved back keys should be pressed continuously for 15 seconds. The list of parameters that can be changed are the battery low voltage set point, the battery high voltage set point, battery charging voltage through solar, and the battery charging current from the solar, the same voltage and current values for grid, then the frequency, and at last the battery reconnect voltage. All these settings can be changed from its default values to the required voltages for the particular battery what we are going to use with the inverter. The values can be varied by up and down keys and set by the enter key as varied in this video or the manual coming with the inverter. Here the voltages can be varied for different charging stages that we have seen already, and again different voltages for solar and grid mode. Now coming to the panels installed and its wattage. The total power of the solar panels that I have installed is 650 watts alone. Here this one is 330 watts 24 volt panel, and these above two panels are of 160 watt 12 volt panels which are serially connected to each other, and they are in parallel with the 330 watt 24 volt panel. The reason why I have just installed only 650 watts panel alone is a result of a simple load calculation of my house. During daytime, at maximum, I may use 4 numbers of 35 watt BLDC fans. That leads to 140 watt of power, one number of 75 watt normal fan, and one pair of 32-inch LED TV and surround system of 155 watts, and one number of 20 watt of LED lamp. So the total load is 395 watts alone. And if the battery is getting charged during the daytime, then it also takes a maximum power of 143 watts. That can be realized from this simple calculation, means 13 volt into 11 amps. So totally I need to have effective power around 530 watts, right? And out of 650 watts from the panels, we can use maximum of 552 watts alone, which is calculated from the company's claim of 850 watts power from the 1000 watts panel, which means 85% of usable power from the panels, that realized from the PV curve earlier. So out of 550 watt, I can satisfactorily use 530 watts, right? This is the reason why I have installed only 650 watts panel temporarily in my terrace. And finally, we came to the money saving calculations. And from this picture, we can see that I have saved 120 units of grid power since I have used the solar in the daytime. And roughly, I'm using 2 units per day. Okay. And one more thing is, I'm using the smart mode in my COM apply. If I go for PCU mode and at the maximum of the solar panel wattage, I can save up to 4 units per day. That means 240 units per billing cycle, right? So instead of 240, I have saved, for my usage, I have saved only 120 units. So using this 120 units itself, I am going to show you the calculation how much money I have saved in my EB bill. So without this solar units, I have consumed 410 units of grid power. So with that 410 units and with this 120 units from solar, I am going to show you the calculation. That calculation is given here for you. This I have taken from the TNEB website itself. If you go to the TNEB website and from the bill calculator a link, you can get all this information for a particular consumed unit. So here you just see, if you compare all the parameters given here, per billing cycle I have saved rupees 1118 itself. So using this small scale solar installation and also with the minimal solar usage in the daytime, I have saved 1118 units. So if I use whole 240 units in the daytime, so you just imagine about the savings that I can have in my hand per billing cycle. Okay. So thank you for watching this video.